Hello, everybody. This lesson is about common factoring or working towards factoring. You saw in the previous lesson sort of the opposite process, to be honest, where you're multiplying out polynomials. I'll show an example or two of that. So when you're looking at, I should phrase actually too here, the previous to the lesson to multiplying out, we saw that we can get zeros from these, whereas from the standard form that we get for multiplying out, you can't tell the zeros. So we're working towards factoring because then we can convert standard form, in which the zeros aren't obvious, into factored form, which makes the zeros something you can figure out, right? So just as a review of what you saw recently, we know the x multiplies onto both and the 2 multiplies onto both. And so if we wanted to show lots of details, we could show the x times the x from the first arrow, the x times the 4 second arrow, the 2 times the x times your third arrow, and the 2 times the 4. So that, of course, would multiply, each term would multiply to be like an x squared and a 4x and a 2x and an 8. And then you can see that we have like terms here, 4x's and 2x's. So that would combine to be 6x's. Right? So the combined term there. So again, this quadratic here, the zeros are not obvious at all. We know if we graph that by a table of values, we know some things. We know it would open up since it's positive. We know it would have a y-intercept of 8. Other than that, there's really not much you can tell. We don't even know if it has zeros, let alone what they are. If we were to be able to convert to this form, so this is obviously standard form, and then this up here is factored form. So we're going to learn soon how to work backwards like that. And from the factored form, you can tell the zeros easily would be -2 and -4. Right? So the value is obvious. That's why we're going to work towards being able to do that. Right? So same kind of worked out for the next one. Again, obviously, you can pause the video and be an active learner and work through these things and make sure you can do these things yourself as we go. And look for the rest of the video for help or confirmation. So this one here, if you tried it, and then I'll show you the results. Same idea, right? You have the 2x times the 3x and the 2x times the 5 and so on. And so you have like terms of 10x and 3x combining to be 13x. Right? So all good stuff, hopefully. Similar to this, same idea of these, each one multiplying out. And so give it a try and then come back and see the solutions if needed. Everything is all as it is, right? So we get all these standard forms that obviously we can't tell as much from them, right? So that's why we're going to work towards being able to factor. So that's what we're looking at now, is we're starting to work towards being able to factor. First, we're going to look at what factoring means in general. A review of that. So it means to break it into a product, a something times something, right? So we're going to have stuff times stuff, right? You can write it as a product of 2 things or more than 2 things. You have factored it, right? So 15 obviously can be written as like 5 times 3, right? So you can say that 5 and 3 are factors of 15, just like you could say that x minus 3 and x plus 7 are factors of the quadratic x squared plus 4x minus 21. Down here, I talked about possibly more than one factor. So you could do 4 times 3 or 6 times 2. If you keep going, it seems like they're 2 different answers, but they're not really, because each one of these can keep going. The 4 can go into a 2 times 2. The 6 can go into a 3 times 2. So either way, we have a 2, and a 3, right? So this is fully factored. Right? So it's the same either way, a 2 2s and a 3. So the part that we're not doing quite yet, but I just want to make sure it's obvious that that's the goal, right? Is that, we start with a quadratic like x squared plus 6x plus 8. If we could work backwards and factor it, we'd be able to tell the zeros, right? So we have those are factors, obviously, of the x squared plus 6x plus 8. And even more than that, so the zeros are obvious and so on. this stuff we'll be able to do very soon. Okay, next lesson, in fact. But to get there, we're going to look at factoring, common factoring first. So common factoring is a simpler version of factoring. So we'll do that first to get some practice with it. So method one is sort of the introductory method, the starting method, whatever. So let's call it the basic method or whatever. It basically is good to start with. Method two, just to be clear here, method two is really your goal. Okay. Your goal is to be able to do it by method two. So we're going to do the factoring of each of these three quadratics, or each of these. They're not all quadratics actually. Equations. We're going to factor them. And they're equations right now because of the y, but it could have just been 6x. Could have just been 6x plus 3, in which case it's just an algebraic expression that we could factor, right? So they don't have to be equations. It's just the way they're written right now. So the way we're going to do this, we're going to fully factor each term, and then we're going to take factors that are in each term out front. And basically, it's the opposite of the distributive law process, as it says there. So let's factor the 6x. So 6 becomes a 3 times a 2. And then, of course, we have the x. I don't need a dot between the 2 and the x, but it just looks nice. And then a 3 times a 1, and you'll see why I'm going to do the times 1 in a second. Because normally, you might not normally do that. I didn't do a times 1 here, but I could have. But I know I don't need to, so I didn't. But you'll see why the 1 with the 3 is useful. So at this point, you can see that there's a 3 in both, right? So that 3 can come out front. And the distributive law process would tell you, like, if you had something in here, you'd multiply it and you'd get all of these things, right? Well, the 3's already part of that multiplication, so all you really need is the 2 and the x. So if I had a 2x, basically the stuff that's not in common, the leftover bits, right? Once you take the 3 out front, you're left with a 2 and an x. And then in this side, you're left with the 1, right? So again, if you look at the process here, distributive law process, if you did 3 times the 2x, you certainly would get the 6x. So that's check, makes sense. And if you multiply the 3 onto the 1, you get the 3. So this is just as a check. We know that it worked, okay? And notice that we have this thing now written as stuff times stuff. We have a 3 and a 2x plus 1, right? Something times something. Okay, so we have successfully factored it. All right, let's keep going here. So the 8 can be written as like a 4 times a 2 maybe to start out with. And then x squared can be written as x times x. And then 4 can be written as 2 times 2, which then you recognize, oh, this 4 can be written as 2 times 2 as well. So 2 times 2 is the 4 times the 2 times the x's, and then the 2 times 2. So all I'll do is breaking each into as many little factors as we can, which is a very, basic, easy skill to start with. And so then what you can do is you can notice that there's a 2 in both, there's another 2 in both, and there's an x in both. And that's it. So 2 times 2 times x can come out front. In other words, 4x can come out front. The stuff that's left over inside is the stuff that we didn't take out front, right? So we'd have what? A 2 and an x. So let me just undo that. Like the way that went. So we have the 2 and the x. So the 2x goes in there. And here, everything came out. So see how it would have kind of been nice to have like a 1 there as well. So we could just sort of have the 1 left over. Okay. So in this case, I did the 1 in the first one here. In the second one, I didn't think of it. But once you take everything out, you have to recognize that there's a 1, so that 4x can multiply onto 1 and give 4x. You can't have nothing there, right? And of course, 4x times 2x gives the 8x squared. So those all worked as well. So this is common factoring, where you just break it into as many little factors as you can and go from there. Okay, so little weirder numbers here. might kind of throw you. You're like, oh, 21 and 105. I have no idea what can this be, right? So maybe you notice the 21. If you don't notice, you'd be like 21 divided by 2 doesn't work. 21 divided by 3, divided by 2 doesn't work because it gives 10 and a half, right? So looking for even numbers, whole numbers, not even numbers, whole numbers. So divide by 3, of course, gives you 7, or maybe you know your times tables well enough to know that 7 times 3 is 21. And so this thing factors like that. The 105, I don't really have a number for 105 in my times table memorization. So we start with 105 and you just divide. Like, what can it be divided by? So you might notice, of course, it ends in a 5, so it can be divided by 5. So you actually get a 21, right? And so then you're like, oh, okay, I get it, hopefully. Where you say, okay, this thing, add over a little bit, give myself some room, could be written as 21 times 5, which could then, of course, be written as 7 times 3 times 5. Or you might recognize, instead of doing that, notice that the 21 is in common. So you pull out the 21, like that, and we're left with what? The x. So you have to multiply onto the x's. So the 2x's is x squared and the 5. Right? So if you look, 21 times x squared, maybe I should do a different color, like a very separate process, not really part of the question, but checking. See, like, that gives that. So, yep. And that, yep. Everything's good. That's just a check. Right? Once you get to this stage, you're done, but you could still check your work. Okay, so factoring each term completely and then pulling the common bits out front is certainly a very functional way to go about it. Method 2 is you should start to be able to think of it as noticing what the greatest common factor is. So the greatest common factor in this case is a 3. A 3 is what can divide into both. Right? So if you do that, you can take that greatest common factor out, and what's inside is what you get when you do those divisions. 6 divided by 3 is 2. You got the x going with it. 3 divided by 3 is 1. So done. And the same checks could happen, right? You could still do the check here and see that you get these. Right? So obviously way quicker, but it's based on some understanding that sometimes it's a little hard to get first try. Okay, so the first method that I did with the green helps us get there. The idea. What can divide into both of these? You should notice a 4 can divide into both terms. 4 divides into 8, 4 divides into 4, and an x can divide into both. So really, if we show that we're dividing out that 4x, bringing it out front, that's the lingo, that's how we refer to it, right? The 8 divided by 4 is a 2, and the x squared is x times x. So x divided by x is a 1, because anything divided by itself is a 1. So you have 1x. Well, there's the 1x. I don't need to write the 1. 2 times 1 times x is the same as just 2x. And then 4x divided by 4x. Again, anything divided by itself. It's just a 1. Right? So same as before. It's all good. And then this one back here, again, you might have had to, do some work to do with the 105, right? You're like, divided by 5, this is 21. You're like, okay, the 21 can divide into both. So that brings a 21 out front. And this is an x squared and a 5. So we are going right. I had problems making this video early, so I'm shell shock here, making sure things are going. So you need to be able to factor both ways, but of course, method 2 is the goal, right? The one you want to be able to do, higher level skill. So some examples that I'll go through here. You can try these, and I'll just go through the answers on the next page. So press pause if you want to try them. We're back at it here. So if you were breaking into common factors, 5 times 2 is 10, 2 times 2 is 4, and so on and so on. So you'd notice there's a 2 common everywhere, and that's it, just 2. So you'd have the 5 times the x times the x. You'd have the 2 times the x, and you'd have the 3. Take away of the 3. Notice that it is a take away away of 6. So it's a take away of 3. Take away of 3. This one, if you notice, there's a common. Oh, sorry, this one here, we could have said, oh, I notice a 2 can divide in everywhere. It's a common factor of 2. And so the 2 can divide out from each spot and just give those numbers directly without having written down all the individual factors. Same deal for this one. Break a 6 into a 3 times a 2, and the x times the x, and so on and so on. Notice that there's a 3 and an x. So 3x. What's left over is the 2 and the x. And what's left over is a 1. Letters other than x's tend to freak people out, but it's just kind of confusing looking, but once your brain gets used to it, you realize it's the same thing. So m squared is just m times m, right? M times m. And then the n, it's a little bad using m's and n's because it's a little bit hard to tell where one begins and one ends. But m times n is the first one. M times 3n's is the second term. So what's in common? Well, there's an m in each. And, right, there's an m in each, and there's an n in each. There isn't another m in each, so I can't underline the other m. That means I can pull an mn out, and I'm going to be left with just an m and take away an n times n. So take away an n squared, in other words, right? So the m, take away the n squared. Right? Sometimes the numbers can be particularly nasty, but calculators are your friend. You can use a calculator, right? So if you're looking at the 189 number, you might start to think like, okay, well, what factors are there of 189? I have no idea either, right? But you divide by 1 does nothing. Divide by 2 gives you a decimal, I think. 189 divided by 2 gives you a decimal, so that's no good. You want whole numbers. So then you keep trying. You do 189 divided by 3, and you say, oh, 63. All right, I can see I'm onto something here because there's 3 in the other part of the question. So if I factored this thing into, for now, I have the full answer there, but factor this into a 63 times a 3, you can tell we're sort of on our way at least, right? And then you might know the 27 factors to be 9 times 3, or you do the 27 divided by 2 does give a whole number, divided by 3 gives the 9, right? So you have a 9 times a 3 times an x times an x. And then, of course, we just saw, well, the 63, I suppose we could work towards factoring it as well at this stage. Or you just leave it at 63 since they're both 63s. Either way. But 63 divided by 2 doesn't work. 63 divided by 3, you just work through it, right? So it actually works to a 21 times a 3 times an x. So this is going to be a 21 times a 3 as well. 21 is really 7 times 3. So 7 times 3 times 3 times x. 9 is really 3 times 3. So 3 times 3 times the 3xx. And then the 63, it's going to become a 7 times a 3. That's the 21. And then times the other 3. I might just have to double check my work there. So the 27, oh yeah, it needs to be 27 times 3. Times 3 still, right? So 27 times 3 is the 63. So I need the 27 times 3. Then I need another 3 times a 3. So I just lost track of how many 3s, which is something to watch for. So we have the 21, and then we have the times 3, and then we have the times 3. So hopefully that makes sense. So then you're looking at what you have in common everywhere. You're like, okay, there isn't a 7 everywhere. There's 1 in the end, and each end, but not in the middle. There's a 3 common everywhere. Is there another 3 in common everywhere? Yes, there is. Is there another 3 in common everywhere? Almost, but not quite. Is there an x in common everywhere? Yes, there is. So you can pull out 3 times 3 times x. So in other words, you can pull out 9x. So 9x pulls out, and we're left with what? A 7 times a 3 times an x times an x. So a 21x squared. Everything pulled out except what here? My underlining was a little off there. So a 3 and an x. everything except the 7. Right? So that's what that one factors to. And again, it's just kind of ugly numbers, but I guess I had that as a first stage last time, but I'll just get that out of the way because I like what I did this time better. Breaking it down bit by bit as we go. Yeah, I just didn't use the colors as much this time, the greens. Now this one here, if you factor this one, it'd be 3 times x and just a 7, right? So there's really nothing that you can break them all into. Interruption there. That means there's no common factor. And so not everything can be factored. So sometimes you might be asked to factor if possible. So you can tell that one isn't factorable. And then finally, this one here, I'm running out of time here. This one here, you can notice a weird kind of case where there's a common factor of a 2a minus 3b. Pull that thing out front. If you pull that thing out front, then you're left with the leftovers, the 5a and the 6. So 5a plus 6. Okay. Now I just want to show you that it could have been given like this. It could have been given as what, 10a squared for multiplying the 5a on the 2a, and it could have been given as minus 15 ab, so minus 15 ab from the 5a times the minus 3b. And then the 6a times 6 times the 2a, we get 12a, and 6 times 3 is negative 18, so b. Right? It could have been given like that, in which case you would have had to notice that there's a common factor of a 5a in those, and a common factor of a 6 in these. Way trickier to do, okay? But is it doable? Yes, right? It's called factoring by grouping. Not really going to focus on it as much in this course, but I just thought you'd be interested to see that if you did that, this would factor out on this guy. That would give this as your next line, right? Where the 5a pulled out and the 6 pulled out. And then you'd notice the common factor of the 2ab, and it would give the final line the same as this. Okay, so group and clone that one. Okay, so if it was given as the original, we need to factor by grouping. I'm going to say factor groups of 2. Way trickier, of course, but just having seen that it's possible, helps you sort of think about possibilities, of course, right? So, right. So I got to go. I got a class coming in shortly here, and yeah. So the practice page is up here for you, of course. Post questions if you need help. Till next time. Happy mathing.